Hey guys, welcome back. Today we'll be looking at exercise 4F, solving linear simultaneous equations graphically, which is a bit of a mouthful. So, linear equations we've covered throughout this entire chapter. Simultaneous linear equations are when we have two or more linear equations that occur in the same system. These are usually really good when we're dealing with application style problems. Say if you're comparing the cost of two different tradespeople or two different investment accounts or mortgages, home loans, things like that. So the solution for these problems is where those two lines intersect or cross over, literally on a graph. So today we'll be graphing two lines on the same set of axes, finding the point where they cross over, reading that off the graph, and that will give us our solution. This is the easier of the methods to solve linear simultaneous equations, but I feel like it is that little bit more time consuming because you do have to draw the graph. So we'll jump straight in with an example. On the screen, we've got two linear equations, y equals 3x take 2 and y equals negative 2x plus 4. Okay. We do need to graph each of these, so I'm going to color code them. I'll do two different pen colors with them. Don't mind the sound of paper rustling in the background. I need that for when I graph things later. So, dealing with the first equation, y equals 3x take 2. You might remember from a previous exercise, to plot this graph, we need 2 points. So, I always like to substitute in x equals 0. When x equals 0, y equals 3 times 0 take 2. Obviously 3 times 0 is just 0, so we get y equals negative 2. So here is a point on our graph. We need another point. We need 2 points to draw this straight line. So I'm going to substitute in this time, let x equal 1. Okay. We get y equals 3 times 1 take 2. 3 times 1 is obviously 3, and 3 take 2 is 1. So 1, 1 is a point. And we need to be able to graph these 2 points on an axis. Here are some I prepared earlier. Bear with me while I try to draw this out on the computer. I'm going to try and use a ruler for this. So I want to plot each of those 2 points. Over here, I needed 0, negative 2 as my y-intercept. If it lets me draw it. Okay, there's a point. And I just am going to try and match that up with a pen on a piece of paper. Okay. I also need to, don't mind if it gets really messy, I'm trying to do this on paper so that I can actually see what I'm doing on the screen. And it's not doing what I need to do. Oh well. Okay. So there's a point, and over at 1, 1, so I go to x is 1 and y is 1, and I'm going to draw a point right there as well. Okay, and now I just need to connect those 2 points. So to do that, I'm going to connect them with a straight line, which did not work as well as I'd hoped it would. Oh well. I might have to freehand this. Okay. Bear with me, it's not going to be a very nice line, but we'll roll with it. Oh, that was better than me trying to use a ruler. Okay, so there is our first graph. We need to do exactly the same thing with our second line. So now I'll work in green, y equals negative 2x plus 4. Again, I'm going to let x equals 0 as my first step of working to find the y-intercept. So y is going to be negative 2 times 0 plus 4. 2 times 0 is, or negative 2 times 0 is of course 0. So we get y equals 4. 0, 4 is a point. We'll graph that over here. 0 up to y equals 4, and I'm going to draw a straight line. A point, sorry. Also again, I'm going to let x equal 1. So this is my gradient intercept method. Y now equals negative 2 times 1 plus 4. Negative 2 times 1 is just negative 2, so you can ignore this bit here. Negative 2 plus 4 is 2. So we get 1, 2 is also a point, and I'm going to plot that over here. So 1, 2. Going to connect them with a straight line. When you guys do this in your books, it's going to be much easier. I can now attempt to read the point of intersection off my graph. Unfortunately, mine is very messy. And the point of intersection here is what you would read off your graph. Now you'll be drawing yours nice and neatly in your books with a ruler. You will not be trying to freehand it on a computer screen. Unfortunately, our solution is actually a fraction or a decimal. So when I complete this correctly or using technology, I get this point here spat out at 1.2 and 1.6. So it's very, very close to the 1, which is not too bad. And the 1.6, it looks like it's at about the 1.5 mark. So even though I've drawn it pretty dodgily, the solution is still pretty close to what it should be. I don't believe that the questions in your textbook will have weird fractional answers. I've just picked a random set. But of course, if you have a CAS calculator, you can plot both of the graphs using the graphical function on the CAS on the same set of axes and then find the point where they cross over from there. Have a look online. There are some really handy tutorials, or I'm happy to send you across a link if you are not able to find one. But that's all for today, guys. Let me know how you go with the work. And of course, I will respond to any messages that you may have as soon as I can. Good luck.